look at now the second question. So now your projectile is fired with an initial velocity of 244 meters per second. So I have here, I'm standing here, and then there is uphill going. So from this point, it is fired with an initial velocity of 244 meter per second. So what will happen? That will go in a path and then it will reach somewhere here. So that's point B. This is point A. So this path is a projectile path. So if you look at the path equation, you can prove that to be a projectile path. It's a quadratic equation, right? So this is point B, and this point B is at an elevation from here, 610 meters. 610 meters, and the same point from A given, B value is 3658 meters. 58 meters. So now what I know what is coordinate B. If A is 0, 0, I know what is coordinate B. That is x 3658, 610. That's coordinate of point B. That's given. So now what is asked here is neglecting air resistance, importantly for projectile motion, determine the value of angle of fire. So this angle alpha is not known. So you have to find what is that angle it is fired, so that that bullet goes and fall on this fixed point. Suppose you have to have a target here which is to be shot, then what angle with this velocity bullet can hit it? That's a question. So how do you solve this problem? How can you solve this problem? How can you solve this problem? So let me do in the similar fashion. I will resolve this motion into two components. One is this, another one is this. So this is 244 cos alpha, 244 sin alpha. So these were the initial velocities. So this is horizontal component, this is vertical component. As it is given air resistance is neglected, this remains constant. This remains constant. So VA equals VB. So VA means what? VXA. VXA equals Vx at point B. Horizontal component velocity is constant. Whereas the Vy is not. So it can happen that it can go and hit it here without achieving the highest elevation, or it can also have highest elevation and fall. We do not know that. It depends upon what angle that you are firing. And in this case, if you look at, interestingly, you can have two angles with which I can fire and have a target. That's what you will understand. Because while solving, I will have a relationship in a quadratic equation form of alpha. That's essentially going to be my path equation, and that equation is what I'm going to solve. So now how do I solve this problem? It's very straightforward. Now let me take first the horizontal motion, uniform motion. So that equation is x is equal to x naught plus v x naught t. So this is 0 as point A is our reference. That's going to be 244 cos alpha t is what is x. So from this I have what is t. That's x by 244 cos alpha. That's the equation. Then let us consider a vertical motion. This is horizontal component motion, right? Well, I'm not saying horizontal motion, horizontal component of motion. For convenient, I'm resolving the motion into horizontal component of motion. And another now I'm going to look at is vertical component of motion. So in that, what is the equation that I'll take? I know now my elevation here, same. Y is equal to y naught plus Vy naught t minus half g t square. Right? Minus half gt square. This is the formula. So in this, if I substitute now my t, I'll have my path equation. But what is that in the path equation? I will not know this alpha. So if I substitute now this in this, that's going to be vy naught in our case is 0, so that doesn't appear. Sorry, y naught is 0. Vy naught is this 0, that is 240 sine alpha into this is x by 244 cos alpha minus half into g into x by 244 cos alpha square. So I can further work on this. So y now. So this point I'm going to apply. This is my path equation. See y, and I have here x, and I have here alpha. So if x is known, alpha is variable. If alpha is known, x would be variable. So in our case, x is known. So if I substitute that here for the point B, so this is yb and this become xb. So I can substitute the value for at point B. This equation become y value is 610, that's equal to 244 sine alpha divided by cos alpha is there. So you can just take that as tan alpha x, and you see this 244 down, that will go off. So it's simply x into tan alpha first minus half 9.81 into so this 244 is outside. Let me take it out. And this 1 by cos squared theta become secant square theta, which is 1 plus tan squared alpha into x square. So that's my equation now. All right. So look at now what would be further happening is. So this is I can see now here tan alpha x value I can substitute, right? X also is known, so substitute that here. So it's going to be 3658. That's x tan alpha minus 9.81 by 488 into 3658 square into 1 plus tan squared alpha. So now this is all equal to 610. So I see here tan alpha, you see here tan squared alpha. So it is quadratic in alpha. So I will have my, if I work further this equation is going to be deduced as this. Yeah. Yeah.
So the 244 in the denominator squared, right?
244?
In the denominator of
equation 1. So it's 244 square, right? I made a mistake. Into 2 here, one more 244 will be there. Yeah, correct. You're right. Because this is inside the square. So 244 square into 2. So I can make this as square, and this is 2. Simply, yeah, that's correct. So now this equation further I would be able to deduce. I'll just write this so you can work out later. I will have finally, this is what is my equation. So what is that I have is 1103 tan squared alpha minus 3660 tan alpha plus 1713 equals 0. So this is what I'll get it. So what is that I do? I just find out this value. Here's the 1 plus tan square alpha. So there will be a constant term, which is with minus sign, that goes on this side. So I will have here my equation reduces to this. So in this now I can solve this is simple quadratic equation your calculator can solve. So this will give you alpha values 2. One alpha value will be 29.4 degrees. Another alpha value is 70 degrees. So either of this you will have. So the one which I have shown is appearing like this. So other path can at 70 degrees, 70 degrees. So that can go and fall on this. So you can also have with the same velocity another alpha, which will also reach there. All right. Yeah. With that, we have so many problems of projectile motion. I leave it to you to refer the textbook. I will ask